Good morning. Today we're going to learn how to graph sinusoidal functions, trigonometric functions with all different types of transformations, including phase shift. Just as we've done before, trying to make sense of all that information that's given in our function, we want to indicate and identify all these different parts of my function. It's important to know the amplitude. It's important to know the midline, my omega, which is going to be used in order to find the period. We need to determine the phase shift. The phase shift is going to allow us to find a starting point and an end point of one period. So let's get started. The first thing that I'm looking at is the amplitude. There's my amplitude. So I know that my amplitude is 2. Amplitude indicates the distance from your midline to the maximum point and the minimum point. Midline. Talking about midline. Midline indicates what type of a vertical shift your function undergoes from compared to the parent graph. Y is equal to sine of x. So this means that the midline of the parent graph has been shifted up 1 unit. So my midline is going to be the horizontal line y is equal to 1. The omega. Now in this particular case, in this particular situation, the omega has been factored out of this expression. So we can easily read off the omega. Otherwise, the omega would always be your coefficient in front of your variable x, in front of your independent variable. So my omega, therefore, is 2 omega. So there's my 2. And now, with the omega, we can determine what the period is. Now remember, in order to find the period, we use that little formula 2 pi divided by omega. So we get 2 pi divided by 2, and that leads us to understand that for this particular function we have one period, one complete wave of your sine function is going to have pi units in length. Phase shift. Phase shift, we can read that one off the function. There's my phase shift. And remember, the standard form would say x minus h. Standard form of this function would say x minus h. So my h is my phase shift. My phase shift therefore is, let me just underline this in color. The phase shift is pi over 4. Now, just as with quadratic functions, just as with our log functions, what we studied in semester 1, we are going the opposite direction of what you would expect. So this is pi over 4 units left. With all this information, now we can determine where is the starting point of my graph. We definitely have this horizontal shift, because the phase shift is a horizontal shift. And so the entire graph has been shifted to the left pi over 4 units. So how do I find the starting point? Well, remember, with the parent graph, y is equal to sine of x. If my angle is 0, my sine is 0. So my starting point for the parent graph would be at 0, 0, or 0 for the x coordinate. But now that we moved to the left pi over 4 units, I know that my starting point is going to be at a negative pi over 4. Pi over 4 units shifted left from the origin, or from the intersection of the y-axis and the midline. That's really what I should say. So that tells me, understanding that the sine always starts from the midline, that tells me that my starting point is going to be a negative pi over 4, 1. Because my graph starts at the midline, and my midline was on the line y is equal to 1. So now we need to find the endpoint. And the endpoint, think of it as the starting point plus 1 period. Now my period is pi. My starting point is a negative pi over 4 plus pi. Pi with a denominator of 4 is 4 pi over 4. So my starting point is going to be 3 pi over 4 for the x-coordinate. There's my x-coordinate. And just as we know from the parent graph, the way for one sine function, the sine wave for one period ends up at the midline again. So now we have my starting point, I have the end point, I have all the information needed for me to graph the function. So here is my x-axis, there's the f of x-axis, and to start off graphing, I really want to use the information that I found. So the midline is going to be at y is equal to 1, so I'm going to sketch in a dotted line. Then the amplitude is 2, so in order to help myself indicate to myself what is my maximum height going to be for this particular function, what's the minimum height going to be, which means I'm going to go 2 units up from the midline, I'm going to go 2 units down from the midline, and these dotted lines are going to indicate to me that my graph has to be in between these 2 lines. So now let's plot the first point. My starting point is at negative pi over 4, so I'm always using the scale along my x-axis that is determined by my phase shift. So I have a negative pi over 4, 1. There's my starting point. It's a positive sign, so I know that my sign is going to go up. But first, before we put in the rest of the points, let's plot the last point. So this is 0. Here is pi over 4. There is 2 pi over 4, or pi over 2. Here is 3 pi over 4. And here is pi. So now remember again, my period is pi. I started negative pi over 4, so let's see, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So just as we found out here, my end point is going to be at 3 pi over 4, 1. So now that I have my starting point and my end point, I see that I have 1, 2, 3 equal distances. So I know that my sign is going to go up. So when my x is equal to 0, I'm going to be at the maximum. Then I'm going to go back to the midline. At pi over 2, I'm at my minimum. So now let's connect the dots. And we have graphed the function f of x is 2 times the sine of 2, parentheses x plus pi over 4 plus 1. I hope that was helpful.